Hello, my name is Bilkent. It's my first year at Bilkent University Industrial Engineering Department, and today I'll present you my PHYS-102 lab project. The effect of dielectric thickness on capacitance and energy storage in a parallel plate capacitor. The equipment used in this experiment is aluminum foil as the conductive plate, stretch film as the dielectric material, capacitance meter, DC power supply, voltmeter, ruler, micrometer, multimeter, and a non-conductive base. The procedure. First, we constructed a parallel plate capacitor by cutting two pieces of aluminum foil for the plates. We placed layers of stretch film between them as dielectric. We placed the setup on a non-conductive base to avoid interference. Using a ruler, we measured the plate area, and with a micrometer, we measured the separation between the plates, starting with 10 layers of stretch film. Next, we connected the plates to a DC power supply, setting the voltage to a constant 20 volts. We used a capacitance meter to measure the capacitance for each setup and a voltmeter to double-check the applied voltage. We repeated the experiment by increasing the number of stretch film layers to 20, 30, 40, and 50, recording the capacitance each time. The stored energy for each configuration was calculated, and finally, to improve the precision of the experiment, we repeated the measurements twice and calculated the average values. We tested the relationship between the electric thickness and capacitance in a parallel plate capacitor. According to the theory, capacitance decreases as the separation between plates increases. Since energy storage depends on capacitance, stored energy would also decrease as the thickness increased. The results were consistent with our theory. The capacitance and stored energy both decreased as the number of stretch film layers increased. In the graph of capacitance versus number of dielectric layers, we saw a clear downward trend. The capacitance dropped rapidly at first and then more slowly at higher thicknesses. Similarly, the graph of stored energy versus number of dielectric layers showed a matching decrease. Thus, the experiment confirmed that capacitance is inversely proportional to dielectric thickness, and that stored energy follows the same trend. Although our results were generally in line with theoretical predictions, there could be some small errors due to the air gaps and bubbles between the stretch film layers, the non-uniform thickness of the stretch film, the flexibility of the dielectric material causing local variations, and the limited precision of the capacitance meter and multimeter. The uncertainties in our measurements were about 2-3% for capacitance and about 4-5% for stored energy. To reduce these errors, we could use a rigid and uniform dielectric material instead of flexible stretch film, use a more sensitive and precise capacitance meter, and ensure a stable parallel alignment of the plates using mechanical holders. In conclusion, this experiment successfully demonstrated that increasing dielectric thickness reduces the capacitance and energy stored in a parallel plate capacitor. Despite minor experimental errors, the overall trend matched the theoretical expectations. Thank you for listening.